All right, so we're going to start off first. Every single day, you will see on your notes the learning target that's going to be posted. I do not post this information up on the board. I post this information on your notes, so it's always there on every single slide. And it's also posted all up in your Google Classroom. Everything that normally would have been on the board is in your Google Classroom, so you should be able to relate back to it each day to see what was our opening, which our opening today was that calculator tutorial. What is our working period? Our working period is going to be going over a mini lesson on reviewing over integer concepts and then talking about properties. And then what is our closing? Our closing for today hopefully is going to be the IXL. It should be a quick skill that you're able to complete to a SMART score of a 70. Okay? So let's go ahead and get started first. The concept of an integer. So for the concept of an integer, integers is just the set of all your positive and negative whole number values, and it also includes 0. 0 is not considered to be positive or negative. It is its own type of value. It's neutral. Okay? Now, our negative values, when locating it on a number line, are always going to be to the left of our 0, and our positive values are always going to be located to the right of 0. And again, like I said before, 0 is our neutral zone. It is neither positive or negative. It is its own little value. It is neither positive nor is it negative. So for example, if I'm wanting to identify the placement of a 5 and its direct opposite, the direct opposite of 5 would be negative 5. So 5 happens to be located 5 spots away from 0 to the right. And then negative 5 is also 5 spots away from 0, but it's to the left. These are called 0 pairs. 0 pairs happen to be values that are direct opposites of each other, that if you were to combine those together, it would give you a value of 0. They are both an equal distance away from 0. And distance in terms of integers is called absolute value. So they both have an identical absolute value, distance away from 0. That's what makes them a 0 pair. Now, keep in mind, when you are identifying or comparing integer values together, when it's a negative value, the larger the base number is, the smaller the negative value is worth, meaning negative 2 is greater than negative 7. Even though we know 2 to be smaller than 7, when you add that negative sign to it, it has an opposite effect. So the smaller the base number of a negative value is, the larger that negative value is worth. Okay? So with that in mind, use these symbols. These are your inequality symbols. You've got less than, greater than, and equal to. And I want you to identify these values, these comparisons, as less than, greater than, or equal to. Go ahead and take time to do that on your own, please. Let's go ahead and go over this. For problem number 1, we're comparing negative 17 and negative 12. Is negative 17 less than, greater than, or equal to? Fatima? Less than. Very good. It is a less than value because the base is bigger. That makes the negative sign smaller. All right, for problem number 2, we've got negative 5 compared to negative 10. I'm trying to learn y'all's names, so give me a second. Let me post this up here. I need help. Hold on. Okay, tell me your name. Kai. That's right, Kai. Kai, is it less than, greater than, or equal to? Greater than. Thank you, Kai. Okay, and then for problem number 3, negative 7 compared to negative 15. Is that Montserrat? Greater than. Very good. So you should have had less than, greater than, and greater than. Okay, let's go ahead and proceed on. Let's talk about some vocabulary terms that indicate that we're talking about a negative value versus a positive value. We're talking about not just basic math terms, but some terms that we see every day in the real world. So for negative, I'm going to go ahead and use a pink to showcase my negatives, green to showcase my positives. So let's talk about some negative terminology that we might know. Obviously, we know things like less. Less might imply that we're talking about a negative term. Maybe smaller. Smaller might imply that we're talking about a negative term. Anybody have other vocabulary that they can think of that would imply something to be negative? What do you think? Huh? Owing somebody. That is a contextual value. When you owe somebody money, when you are in debt, and I'll even put that down here too, debt off to the side, that is something negative. Okay, what else? Go ahead, Fatima. Huh? Inferior. Okay, we might not see that so much when we're talking about math, but yeah, if you have a more of a language arts terminology, inferior compared to superior. Okay. You know, if you're talking about at work, you've got your superiors who are your boss, and an underling that is somebody who works for you. So, but not so much as math. We're trying to think more in the math terminology. Anybody have anything else? How about when you go to the bank and you have to take money out? Anybody know what that's called? What is that? Huh? Okay, a loan. Or what else? Somebody else said it. What is it? Withdrawal. So taking a withdrawal from your account or taking out a loan. Okay? When you take out a loan or when you withdraw from your own. How about when you are, anybody ever go fly in an airplane? Ladies and gentlemen, please take your seats. We are about to start our, anybody know? What? Landing. We're going to start landing, but what is it called when they start to land? It's, Maggie? Takeoff is to go up. If you're landing, if you're coming down, what do we call? In the back? Oh, descent. Your descent. So if you descend we use quite often in math when we're talking about a value. So if we're descending in a plane, if we are going to descend in the building, meaning like we're going to go downstairs or we're going to take the elevator descends. Okay, see, these are negative terminologies. Okay, decrease, a drop, a fall. These are all considered to be terms that we can use to indicate negative values. Okay, let's talk about the positive values. Okay, basically each one of these can have a counterpart. What's the opposite of less, guys? Go ahead, say it. More or greater. Right? More or greater. You can use either one of those. I'll put them both down. Greater. More. What's the opposite of smaller? Bigger. Okay. What's the opposite of somebody owing you money? Giving you money, right? Instead of owing somebody money, maybe somebody's giving it to you. We're going to give you some money instead. What's the opposite of withdrawing money? Deposit. Deposit is the opposite of a withdrawal. Oops. My bad. It's Friday. All right. The opposite of you having to take a loan out. Anybody know? Not paying it, you're saving it. So the opposite of loans means that you are actually saving money. So loans means you have to borrow. A savings means you already have the money and they're paying you. That's the nice thing. A loan, you have to pay the bank back. Your savings, the bank pays you. Huh? Well, loan or borrow would be a negative. Saving would be a positive. Or earning. We'll even put earning money. Okay, opposite of descend. Ascend. Good. So when we take off, we are ascending. Opposite of decrease, Lucas? Increase. And then the opposite of a drop or a fall. Instead of dropping, like if you're on a roller coaster dips down, it rises instead. That's the opposite. Good. Shout it out, Lyndon. Don't wait. Just shout it out. All right, let's go ahead and flip it on over to the back. And when in doubt, if you ever get to the point where we're going too fast for you to write things down, where can you find this material again? Google Classroom. You can always skip through the videos and just find the slide that you weren't able to catch up on. Okay? All right, taking a look here. We've got some examples of positive, negative, or zero values. Things that would actually represent a neutral zero value. It's not a positive, it's not a negative. I want you guys to go through these and identify those very quickly. Just indicate it as positive, negative, or zero. All right, let's go through them real quick. If we gain 6 pounds, is that positive, negative, or zero? Just shout it out. Positive. Okay, that would be a positive 6. Our weight went up 6 pounds. If it's a loss of 10 yards, positive, negative, or zero? Negative. That is a negative 10. Okay, 1,000 meters above sea level, positive, negative, or zero? Positive. Positive. So we're going to put a positive sign and 1,000. You owe $50. Negative. Negative. You are at ground level. Zero. That would be considered a neutral value. You are neither above or below. 17 degrees below zero. Negative. Negative. Good. Sea level. Zero. Okay. Depositing $142. Positive. Positive. And then descending 2,500 feet. Negative. Negative. Okay, so absolute value, like we discussed before, absolute value is that distance that a number is from zero. Distance is always positive, guys. It doesn't matter how you look at it. If you're in a car and you're driving your car in reverse, it's still going to have that odometer calculating your mileage. It's still going to be increasing your car's mileage on there. So it does not matter the direction that you are moving. It's still positive because it's distance. So absolute value is always a positive value. Now, absolute value kind of acts like parentheses in a situation. So if you've got an order of operations problem and you've got absolute value, you always want to do the absolute value first. If you have a problem inside of your absolute value, you want to solve the problem first before you find the absolute value. Once you find the absolute value bars are gone, and then you continue to work the problem out with whatever's still left. So for problem number 1, the absolute value of 4, how far away is 4 from 0? 4. It is a positive value. How far away is negative 30 from 0? 30. How far away is negative 4 from 0? 4. Now here we've got absolute value of negative 3, and then on the outside we have a minus 5. So we have to do the absolute value first. So what is the absolute value of negative 3 going to be? 3. So we now have 3, and then the rest of our problem, minus the 5. Now, you guys may remember that we don't actually subtract in a problem. We really are doing the additive inverse. We are adding the opposite value. So we never subtract, we actually add the inverse of the second value. So this is really going to be a keep your first value. We're going to change that subtraction into addition, and we're going to change the 5 into its opposite. So this really becomes 3 and then plus a negative 5. And 3 plus negative 5 is what, guys? Well, yeah, we already know 3 minus 5, but what is 3 minus 5 or 3 plus negative 5? Negative 2. Very good. Okay, so this is going to be a negative 2 for our value. Here, we have a negative and then an absolute value of negative 15. So we have to do this absolute value of negative 15 first. What is the absolute value of negative 15? 15. Now this negative sign that was on the outside of our absolute value is still going to come straight down. And so this basically is what value? Negative 15. Okay. Then we've got the absolute value of the quantity 4 minus 7. And then outside of the absolute value, we have a plus 9. So that means we have to do this portion right here first. We have to do that 4 minus 7 first. What is 4 minus 7 going to come out to? Negative 3. And then we can go ahead and take the absolute value of negative 3. What is the absolute value of negative 3? 3. And then we can do 3 plus 9. What is 3 plus 9? 12. So our final answer here is a positive 12. Okay, we are out of time. We will finish the lesson on Monday. You have no homework tonight.